I am Alrashidi from University of Florida. So today I'll talk about the evaluation of non-proprietary ultra-high performance concrete resistance to chloride penetration. So I'll start my presentation with a short background, and then I'll touch upon the research hypothesis, and we will talk about the experiment that we have done. And finally, I'll give a short summary or conclusion. So UHPC is a new class of concrete made with fibers to provide a high compressive strength and ductility. UHPC, also known with its superior mechanical and durability properties when compared to the normal concrete. UHPC has a very dense microstructure, or I would say non-continuous porous structure. So this makes it actually really difficult to use certain durability test method that is used for normal concrete. So some modification to these tests need to be done in order to make them work for UHPC. And also nowadays, concrete plants also begin to produce non-proprietary UHPC. So it's really important to have some modification to the durability test in order to measure their specification. So we have two main hypotheses. First, if we look at to the, let me just use the laser pointer. If we look at to the FDOT concrete classes, there is a whole range between the normal concrete and UHPC. That is probably a good concrete, but we are not taking advantages of. So the first hypothesis is that in this range, there is a compressive strength at which point the porous structure becomes discontinuous and the chloride ingress does not penetrate more than a few millimeters into concrete. The second hypothesis, since UHPC has a steel fibers, we believe that the modification to the rapid chloride migration test can be used to measure the resistance or to measure the chloride penetration. So to answer the hypothesis about that the RCM could be used for UHPC with the steel fibers, the modified rapid chloride migration test was compared with 5 other tests. First is the surface resistivity and the bulk resistivity and the water and the isopropanol absorption and the MIP and the bulk diffusion. So I believe we don't have time to talk about all of them, but we will talk about some of them. So the samples were made with 3 different steel fibers content with 0%, and 1.5%, and 2%. And we have used 3 different curing methods. First is the fog room. After we demo the samples, we immediately put them in the fog room until testing. For the steam curing, after we demo the samples, we put them in a pan with water and we put them in the oven for 2 days at 194 Fahrenheit. For the precast, so after 4 hours away from the mixing, we placed the samples while they are in their molds at the oven at 158 Fahrenheit for 18 hours. After 18 hours, we demoed them and put them in the fog room. So, okay, for the modified RCM, the samples were cut and then vacuum saturated with lime solution. Then they were placed in rubber sleeve and placed in solutions, the NaCl and the sodium hydroxide. So for normal concrete, usually it is tested up to 2 days. But for UHPC, we made it up to 10 days to allow more chloride to get in. So we were using 30 volt for 3 and 7 and 10 days. Then after the testing is done, we cracked open the samples and we sprayed it with 0.1 silver nitrate to determine the chloride penetration. So for the bulk diffusion samples, the samples were cut and it was epoxied from all sides except the cut surface. And then we soaked them in tap water for 48 hours. Then we submerged them in a 16.5% of salt tank in DOT tank for a year. Then after that, we got them and we grind them into thin layers. 1 millimeter for the first 6 layers and 2 millimeter for the last 4 layers. So also we left some samples in the tank for later testing. And here is just to show the compressive strength for the durability samples. And it is clear that the steam curing has the highest compressive strength, followed by the fog cured samples. Then the last is the precast. Okay, so here is the RCM result. That 21 KSI showed an extremely low chloride ingress, 6 millimeter at most for the fog cured samples, and less than 3 millimeter for the steam and precast cured samples. It seems that the chloride penetration did not go for much further with time, especially for the steam cured sample, the one in the red dot. For the 18 KSI, it showed similar type of results to the 21 KSI, but with a slightly higher chloride ingress. For the 15 KSI, it showed again higher chloride ingress when compared to the 18 and 21 KSI, and it is as expected. As the strength of the mixes decreased, the chloride ingress increased. But when it comes to the lowest strength, the 12 KSI, the chloride went completely throughout the whole samples, especially for the one with 1.5% and the 2%. So for the 2%, we had to stop the test at 3 days because it showed like really high current due to the presence of the fibers. And here is just to show a picture for the 12 and the 15 KSI mixtures. And we can see here it experienced like really significant cracking during the testing. And here is our bulk resistivity results. The Federal Highway Transportation proposed a limit of 150 kilo ohm per centimeters for UHPC samples with no fibers. And we can see here the fibers like 1.5 and 2% really affect the resistivity measurement. So based on the proposed limit by Federal Highway, if we rely on this one, the only mix that would pass is the highest strength mix, is the 21 KSI mix. But we believe this value is a bit subjective. Why? Because first, it was meant for proprietary mixes, and usually the non-proprietary mixes has lower strength than the proprietary mixes. Second, it was only meant for the standard curing method, and for the fog curing. And for the steam, the precast, we can see here, it already exceeded the limit of this proposed limit by Federal Highway. So it does not work for all the curing method as well. And here is the MIB data for the 21 KSI and the 12 KSI samples. the 21 KSI mixture showed almost 2 times less mercury intrusion than the 12 KSI mixture. The 12 KSI showed an S shape with well-defined curve, but we can see for the 21 showed a flatty curve, which makes it really difficult to establish the critical pore diameter. And based on my experience, this means it has too low porosity, especially if we can see the steam curing samples. It has almost like flatty lines, so we cannot establish the critical pore diameter. And here's just to show how the mercury intrusion reduced and the pore size decreased as the strength of the mix increased. So here's the 12, and here's the 15, and here's the 18 and the 21 KSI. So for the bulk diffusion result, the 12 and the 15 and the 18 showed chloride penetration of 10 millimeter or above, as compared to only 5 millimeter for the 21 KSI. And also the steam cured samples show similar trends as the fog cured sample, except that 12 KSI showed like higher ingress, which agrees actually with the RCM data. It is just to compare the RCM to the bulk diffusion test, and for the at 3 days we see a good R square between them, and at 7 days we see actually better correlation between the RCM and the bulk diffusion. With especially for the steam curing is almost like 0.91, and the fog room did not correlate well, and I think because that it also like it's still like continued hydration. And here is the correlation for the 10-day RCM, and we see that the 7 days showed like better correlation with time, because after 7 days there is no more chloride penetration. And in summary, the discontinuous pore structure eliminated the effect of fiber on modified RCM mixture above 15 KSI. The fiber affect the resistivity measurement really well, so it is really difficult to use it for the resistivity measurement. The modified RCM test was found to work well for HPC samples with fibers up to 2%. So if anyone wanted to try it with 2% and above, they need to do like more experiment, because our just below 2%. So we found also the steam cured sample with the RCM gave conservative result at 28 days, and a limit of 5 millimeter of chloride penetration after 7 days of steam curing was found to be a good limit of differentiating chloride diffusion performance. I would like to acknowledge the FDOT for funding this research, and Michael Thomas for his discussion on UHPC and his insights into its durability. The advice of Steve Nolan and Dale from FDOT also are acknowledged. So the Stephanie Wood, so we put some samples in the Treat Island, and we appreciate the help of the Stephanie Wood. And with that, that's it. Thank you so much. Any questions?
Thank you, Raid. Do we have any questions for Raid? Yes, we have a question.
Just a comment. I was looking at the steam curing. Was a little bit worried about the risk of plate activation or DEF.
Sorry, I cannot hear the question.
Yeah, give us a second.
Okay.
So I was just curious about the steam curing, because from typical steam curing or normal strength concrete, because your temperature was probably above 75 or 80 degrees Celsius. So in that
Correct. It
case,
was 90 actually.
yeah. So in that case, based on existing literature, there may be a risk in the long run in terms of delayed entry-gap formation or DEF.
Yes.
Have you considered that?
We actually did not consider that. So we actually found that the steam curing method, like for the when compared to the fog and precast and the steam did worse than the others for the when it comes to the low strength. But with the OHPC, it's really good.
Okay. All right. Thank you.